All right, team, let's go ahead and talk about some of these questions. And so if we're looking at this first one, which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of the vertex can be identified as constants in the equation? What this is saying is that we need to be able to easily pull out the x and y values of our vertex super easy from our equation. And we just talked about the form of our quadratic where that is going to be the case. And that means our equation needs to be in vertex form. And so when I'm looking at these answer choices, right, the only answer option that is in vertex form is option D. And we can see that, like, if we are looking at this graph, right, it looks like our vertex is at 1, maybe like around -15 or so. We should see that vertex show up in this answer response, and it does, right? This -1 means we're at a +1 for x, and this -16, whoops, I guess it is a -16, not a -15, shows up for our vertex as well. And so super easily, right, knowing what we understand about vertex form, we could really easily answer this question. All right, let's move on to number 2. So which of the following is an equivalent form of the function in which the minimum value of f appears as a constant or coefficient? Whenever we're talking about the minimum or the maximum of a quadratic, right, we are talking about the vertex. We're looking at this on a graph. We're talking about the minimum. We are talking about the vertex. And so this was the SAT's discrete way of saying, hey, I need my vertex to appear as a constant or coefficient in my equation. Again, we know a form where the vertex is very easily to pull out, and that is vertex form. And so when I'm looking at these answer options, right, I can already get rid of A. I can already get rid of B without necessarily having to do any math so far. And now we're down to C and D. And so for me, I am going to focus on the x value, right? And I need to figure out what the x value of my vertex is. Well, when our equation is given to us in factored form, right, the way we did that was by graphing our x-intercepts, because our x-intercepts are really easy to get from this, right? We have 1 at 6, -6, 0, and then 4, 0. So I'm going to graph those points, right? -6, 4. My a value, again, is positive, and so I know my parabola is facing up. I'm looking for the number that is in between -6 and 4. We'll go ahead and do the average of these two numbers, just like we've been doing, so you can see exactly how to get this. So -6 plus 4 divided by 2. -6 plus 4 is -2. -2 divided by 2 is -1. And so that means the x value, my graph isn't perfect, of my vertex is -1. And what that's going to show up as in my vertex form is a +1. And so it looks like option D is my answer for question number 2. All right, let's talk about number 3. The function above models the height, h, and feet of an object above ground, t seconds after being launched straight up in the air. What does the number 72 represent in the function? Well, again, we know from what we talked about, if we see the equation of our quadratic in standard form, we are looking at this constant, that is our y-intercept. And so if we write our y-intercept as a point, and we think about what each of these numbers represents, right, the 0 represents seconds. The 72 represents the height in feet of an object above the ground. So 72 represents height. And we can go ahead and say, like, in feet. Okay, and so when I'm looking at these answer options, let's see, option A, the initial height in feet of the object. Okay, nice. We just talked about how 72 represents height in feet, so I like that. Let's go ahead and continue. Option B is the maximum height in feet. Okay, so the difference between answer A and answer B is this word initial versus maximum. We'll come back to that. C is the initial speed in feet per second. No, we're not talking about feet per second or speed. Same thing for D. We're not talking about speed in feet per second. Now let's come back to option A versus B, initial versus maximum. Well, again, initial makes sense because we are talking about our height at 0 seconds. That is going to be our initial height. This y-intercept is not necessarily our maximum, right? We don't know that for a fact. But we do know, yes, at 0 seconds, that is our initial height of the object. And so we're going with answer option A. Sweet. Let's go ahead and continue with some more practice. Okay, so for this question here on the left, we see that we are going to need to use the quadratic formula because each of our answer options, while I cannot talk, is in the form of the quadratic formula. And so when I put this into the quadratic formula, get x equals negative b, so negative 12 plus or minus the square root of b squared, which is 12 squared, is 144, minus 4 times a, which is 3, times c, which is 6, all over 2 times 3, which is a. I'm just going to write that as 6. All right, again, this is going to be a question that you don't necessarily have a calculator on, and so we need to do some mental math. And so if I'm looking inside of my radical, I have 144. Looks like minus 4 times 3, so minus 12 times 6. Let's see, 12, 24, 36, 48, 60, 72. So 144 minus 72. What's that going to be? 144 minus 70 is 74 minus 2 is 72. Oh my gosh, wait, that's literally just double. Okay. So 144 minus 72 is square root of 72. So we have x equals negative 12 plus or minus the square root of 72 all over 6. All right, this is where we need to think about how we can break down or simplify this radical. So we're looking for any perfect squares that are factors of 72. And when I think about that, well, 72 divided by 2 is 36. Oh, which is a perfect square. That's perfect. All right. When I do this, x equals negative 12 plus or minus, well, this is like the square root of 72 if we break it up into 36 times 2. The square root of 36 is just 6, so I can pull out that 6, and I'm left with just the square root of 2 inside my radical, all over 6. All right. Last thing we can do is pull out that GCF of a 6. I'm going to write that over here. Sorry, my work is all over the place. If I pull out a negative 6, I'm actually just going to pull out a positive. It looks like my answer choices have some negatives in there. So 6 times negative 2 plus or minus the square root of 2 all over 6. We see that our 6's cancel out, and we are left with x equals negative 2 plus or minus the square root of 2, which looks like that is option A. X equals negative 2 plus or minus the square root of 2. All right, I'm going to go ahead and erase my work so I can do the other problems. And then we can go ahead and get started with the second one. Okay, so for the second question, we are going to want to use the square root method because in the equation ax plus 3 squared equals 36, a is a constant. If x equals negative 3 is one solution to the equation, what is the possible value of a? So I'm going to plug in negative 3 for x. So negative 3a plus 3 squared equals 36. I'm going to square both sides. Sweet. I get negative 3a plus 3 is equal to plus or minus 6, right? Very important we have that plus or minus because we are doing the square root of 36. And now I can go ahead and solve. So negative 3a plus 3 equals positive 6. Negative 3a plus 3 equals negative 6. I get negative 3a is equal to 3. That means a is equal to negative 1. And then here we get negative 3a is equal to negative 9. So a is equal to positive 3. So if I'm looking for my answer options here, right, a equals 3, not an option, but a equals negative 1 definitely is, and that is option C. And I'm looking for one possible value of a. All right, now we're looking at what are the solutions of the quadratic equation given here. When I'm looking at all these answer choices, right, they look like really nice numbers. And so I know I'm probably going to be able to factor this by hand. And so the first thing I always do when factoring is see if I can pull out a GCF to make life easier for myself. And it looks like I can. If I pull out a 4, I'm left with x squared minus 2x minus 3 is equal to 0. And that is good for us because that's going to make factoring this actually quite a little bit easier on the math. And I can actually do this one in my head. So I'm looking for two numbers that multiply to negative 3, add to negative 2. Looks like that's just going to be negative 3 and plus 1. And so when I solve for my x's, I get x equals positive 3 and x equals negative 1, which looks like option B. All right, which of the following lists all solutions to the quadratic equation above? I think and I feel like some of us, as it is written right now, would be tempted to say, oh, like my x is equal to 0, and I have another one that's equal to negative 2. But you cannot do that, right? Because it is not set equal to 0. It is set equal to some number, in this case 8. And so what we need to do is put our quadratic in standard form so that we can factor. And so in order to do that, we'll distribute this x. So we have x squared plus 2x is equal to 8. Move that 8 to the other side so that now we have everything set equal to 0 and we can factor. When we do that, we're looking for two numbers that multiply to negative 8 and add to positive 2. I believe that's going to be positive 4 and negative 2, which means that our x values are negative 4, positive 2, which is option C. All right, that was some good practice with quadratics on the SAT. Keep practicing in Khan Academy. It is there for you. Let's get this thing going.